part of the Global Water Crisis, Conflict, and Cooperation Symposium. My name is Gary Gabriel. I'm Dean of Engineering here at Villanova. And we have 5 panelists here for today's session to talk about water and technology preventing and mitigating conflict. Our session is appropriate on the potential to exasperate and also prevent and mediate conflict. Our presenters, I have Mark Dunscombe from Schnabel Engineering. Is it Schnabel or Schnabel?
Schnabel.
I thought I had that wrong the first time. Mike Ingalls and Melissa Burns from World Water and Solar Technologies. And Jeff Balu from GE Water and Process Technologies. And our guest respondent is Chris Saareau from CRS. So our day-long symposium on global water crisis has been a collaborative effort of both CRS and the colleges and schools across the university. In 2005, Villanova University, together with 4 other Catholic higher education institutions across the nation, entered into a formal relationship and partnership with Catholic Relief Services, the official overseas humanitarian agency of the U.S. Catholic community. The purpose of the partnership is to deepen our institutions' respective and shared mission to reduce human misery, promote justice, peace, and global solidarity through collaborating in global education, research and advocacy and service. And so today's symposium is an example of that collaboration. So our format today is, let me first introduce all the speakers, give you a little bit of background on each of them. Then each of them will speak roughly for about 12 minutes, and then Chris will respond with about 15 minutes of response, and then we'll have about 15 minutes or so for questions at the end of the presentations. So I'll start with Mark Dunscombe. Is a senior associate for Schnabel Engineering. He has over 18 years of experience in geological, geotechnical, environmental applications within the Mid-Atlantic region. He is experienced in geophysical techniques and interpretation, including one-dimensional and two-dimensional resistivity, terrain conductivity, water-penetrating radar, seismic refraction, induced polarization, and spontaneous potential, electromagnetic and magnetic and gravity. He has a host of other areas of expertise, from everything from commercial, industrial, educational projects, and hydrogeological studies of landfill expansions, and clearly is very qualified to be on the panel and provide us some interesting perspectives. Mike Ingalls is Vice President of Operations for World Water and Solar Technologies, provides oversight for research and development and manufacturing programs within the company. He has been with World Water Team since 1996, implementing solar water pumping projects throughout Eastern Africa, Southeast Asia, the Caribbean, and the United States. And Melissa is the Vice President for Projects and Outreach, and she supports government, NGOs, and other organizations to assess their water needs, not only technical needs and how her company might meet those, but also in the different aspects, in the broader aspects of community building. She has a background in public policy, has had positions in both domestic and foreign countries related to that. Jeff Balu is Marketing Operations Director for GE Water and Process Technologies. He came to that position in 2008 from GE Capital, where he led the trailer fleet services and held the role of strategic marketing manager after joining as the product manager for maintenance services. And then finally, Chris Saareau is a water supply and sanitation technical advisor for Catholic Relief Services. He has a Master of Science degree in Environmental Engineering from UMass in Amherst, and a Bachelor of Science degree in Forest Engineering from SUNY College of Environmental Science and Forestry in Syracuse. He has managed water supply activities in refugee camps in Tanzania for International Rescue Committee and acted as water engineer on a typhoon recovery project in Micronesia for Crisis Corps. So, why don't we get started and save as much time as we can for remarks and questions, and we'll start with Mark.
Thank you very much. Thank you. Let's see. Tell you what, we will get presentation rolling here. I appreciate the opportunity to come today, and on a purely personal note, this photograph that you're looking at right here is a channel, an irrigation channel in the Dominican Republic. It's about 1.5 miles away from Haiti. I was there in April, shortly, as you know, after the earthquake happened in Haiti. And we've been working with this, I've been working with this, this village for several years, and very exciting. One of the issues that we've been working with is to bring them water. Their primary source of potable water, if you want to call it potable water, is that irrigation channel that you saw. And obviously it's not a high quality water source. So this is a photo of us taking the first bottle of purified water from this woman's tap. She has water about 2 hours a day, most days, and it's very exciting. So from a personal standpoint, it's neat for me to be here today to talk about water supply in third world countries, and also how geophysics might be able to help in that, to that extent, to bring water, to find water. And so that's what this talk's about. This is about finding water using geophysics. Now, I should talk a little bit before I get into it about all these fancy logos on the side here. One of my other goals is to introduce you to a couple of organizations. One of them is Aegis. I'm on the board. That's the Environmental and Engineering Geophysical Society. They have a foundation. I've been on that board for about 5 years now or so. The SEG, we're working closely with SEG. That's a Society of Exploration Geophysicists. Those guys are mostly, they look for oil. I mean, that's their shtick. A lot of money, and they've been looking for how do we use this money that we had in a good humanitarian way. They formed the foundation. As an offshoot of that foundation, Geoscientists Without Borders started, much like EWB. I'm sure you're familiar with Engineers Without Borders, Lawyers Without Borders. There's almost everything without borders. This started from a company called Schlumberger and the foundation, and they're doing a lot of neat work. And so what I'm going to do is I'm going to show you just a very brief, hey, I've got 12 minutes, so 9 minutes. So I'm going to do a very quick flyover of the concept of geophysics, and then I'm going to give you a case history from Geoscientists Without Borders, where the Colorado School of Mines linked up. They've got a humanitarian engineering department. They linked up with GWB to do some work in Honduras. So I thought that might be interesting, and also show you a real live example as how geophysics can be used to find groundwater. All right. So before I get there, the initial question we have to ask is where do we find groundwater? And that might be an obvious question to a lot of you, but I wanted to bring it up because really, as a geophysicist, that's my target. That's what I'm looking for. And there's two ways that you can find water. You can either look for geologic structure, and that is, you can see over here on the left, there's some fractures in the bedrock. There might be interfingered geologic rock types or formations that are joining and have little cracks in them, all sorts of things. So we can look for that kind of structure within the rock. That's one way. We can also look for the actual water. Say it's in a gravel bed within the soil. It's got a lot of big holes within, pores within the gravel, and so we can look for the actual water. So there are those two different avenues that we can use as geologists, as engineers, to try and find good spots to find places to drill. Let's face it, if I went out and I just drilled a well, odds are I might hit water, and I might drill what they call a duster, which you can imagine what that is. It's a nice, big, deep well that has no water. And so we want to focus that expensive effort of drilling wells to the best possible location. And one of the ways we can do that is using geophysics. Geophysics uses non-invasive tools to try and image what's going on in the subsurface. This is a definition. I'm not really gonna dwell on this other than to say that they're non-invasive methods. Well, you know, what does that mean? Well, you know, we all have our five senses, right? Point is that when something is underground, you lose a lot of your ability to figure out what you're dealing with. You don't have the tactile sense anymore. You may not be able to look down 1,000 feet and feel, is this gravel? You can't see it, obviously, right? You may not be able to hear so how do you extend your senses, those five senses that you have, to try and figure out what's going on? And that might be using radar waves. It might be using other sources of electromagnetics. It might be using passing current into the ground and seeing what happens. And what I'm doing is I'm broadening those types of data input that I can pull together and figure out what's going on in the subsurface. And that's really what geophysics is. Now, to do that, we have to have some sort of parameter that we're measuring, right? And there has to be a contrast in that parameter. So if I'm looking at the resistivity, or how something conducts electricity, I might say, well, you know, if it's a really saturated sand, really sopping wet soil, it might conduct electricity better than just a really thick, hard, massive granite, and that has very little water in it at all. You know, so there's a contrast there. And here's a list. I'm not going to read through them for time's sake, but there's a list of typical parameters that you might look at. Also, a list of tools that you might use. And really, you know, the purpose of this is to show that there are a lot of common tools out there. There are a lot of ways that we can use that are well known. And then, hey, you know, there's nothing saying that you can't make one up or combine several. Get a vantage point of the subsurface from using this kind of a technique. Get it from another vantage point. Maybe one method, one technology is very good at looking for water below or above 100-foot depth. Maybe, as in the case of control source audiomagnetics, CSAM. That might be very good for looking for groundwater in, say, Nevada at 1,000 feet, 1,500 feet. That's not really going to be helpful in a humanitarian sense in a third world country, but you know, maybe that's what you're looking for. So there's all these tools that we can draw upon. All right, so now on to the fun stuff. I want to talk about Chazanigua, Honduras. You can see where it is. It's about central to the west central of the country. Honduras, as you know, is not a wealthy country. It's one of the poorer nations in the Western Hemisphere. And this particular project is actually an offshoot of another project, an earlier project that Colorado School of Mines, CSM, performed in a town called Colinas. There, what they did was they went in, they performed some geophysics, they found a great well site, they drilled it, developed that well site. Their engineering department came in, designed a distribution center and system and a filtration system, and now through some NGOs and grants from a variety of other sources, they're implementing that system. Well, there's a town called Chazanigua not far away that heard about this project, and they said, hey guys, you know, we have to have water trucked into our village at the cost of about $6 a day. for portable water supply. Now it rains a lot there, but there's also coliform in their cisterns, so they were having problems with that, with health concerns. So they came to CSM and they asked, "Hey, can you help us out?" Here's what the village looks like. This is the Wawa, right? The general store. You know, gives you a sense of what the area is like. It's a volcanic terrain, means there's a lot of different rock types. There's also some carbonate bedrock, some limestone. Here's one of the local village houses. And here you go, you can see they're pumping water in. Truck comes around about once a week. All right, so this is classic. This is the kind of project that GWB works with very often. So the idea was to go in with a number of geophysical techniques. Here's some of the instrumentation that they used in this March, I guess a year and a half ago, to do just a very broad brush. These particular methods, I'm not going to go into each one of them, but these particular methods, you can collect data with over a reasonably large area in a quick way. What they did was they covered about a hectare and a half of area in several fields to get an idea, hey, you know, what's the structure going on here in the subsurface, and is this a good place to place a well? They collected, this is a map, a plan view of some of the data, and you can see there's some differences without going into exactly what it means. You can see there's some differences. They interpreted this and they said, why don't we put a well right here, all right? Everything's looking good, bada bing, bada boom, we're good to go. Well, and this is also a very typical thing in these types of situations. They wanted to put this well right in the middle of a field. Well, that was March 2009. Between March and August 2009, someone planted that field with coffee. And the owner said, no, there's no way that you're putting a well in the middle of my coffee field. And so they went back in August, or in July rather, I'm sorry, to collect more data. And I'm going to show you, and you can see them collecting data in the field. I'm going to show you some of the results. Oh, very neat. As part of the process, the townspeople, the village, really got excited about helping. And they were out every day running lines, cables, and being a part of it, being their own advocate. So this is an example of what they came up with in the end. This is a cross-section, and you can see on the left-hand side there, that's elevation, from elevation about 580 meters down to about 440 meters. So that's over, that must be foot. All right, so that's feet. That's over 100 feet in cross-section. And you can see on the left, towards me, there's this red material, whatever that is, but there's also green material or blue material on the right, and there's a very definite connection. Well, this left is that volcanic rock that I was talking about. The right is that carbonate bedrock, the limestone, and right in the middle, they're assuming is a contact, and it's likely to be a fault, and that would be a very good place to find water. So that is the drilling spot right now. They investigated further. They moved it off this gentleman's field, and they're waiting to drill that. CSM, after they drill the well and develop that, they'll design a distribution system. So that is just a very broad brush of some geophysics. Some websites here on GWB, Aegis, the Geophysical Society, and also the mines. I have to give a little plug for them since they gave me this example. They were very kind in that regard. And really, I mean, what you see here on the screen, this is why they're doing it. Because there are people there whose lives are dependent on potable water. All right.
Thank you.
Great.
right. Hi, everybody. So again, thank you very much for putting on this conference, and it's wonderful to see so many people here who are interested in these questions. So my colleague Mickey Ingalls and I are here today from a company called Groundwater and Solar Technologies, and we work in the nexus of power, water, supply around the world. One of the things that we wanted to explore in our conversation with you today is a foundation, setting a common understanding of what do we mean by the global water crisis and its impact on conflict or stability, and then talk a little bit about various technologies that might be appropriate to approaching the water crisis situation, the role technology plays in preventing or mitigating conflict or not, and then the individual private sector and academic role in the water crisis. We all understand that we need water to live. We need water to grow our food. We need water to clean so that we can stop the spread of disease. We also need water for industrial and technological purposes. The clothes that we're wearing, the cars that we drive, all include a water footprint. That said, there's 70% of the earth is water. Only 2.5% of that is fresh water, and then of that, there's still a limited amount that is usable, either because it's on the surface or because it's not overly polluted. Another way of looking at this, for instance, is to think of all of the water in the world. Only 3% of that is fresh water, usable for the purposes that we're talking about, human consumption, industry, etc. Only 0.3% of that is accessible on the surface, and again, only 30% of that 3% is accessible as groundwater. So already we're talking about a very limited supply of water that's usable for not only our life, but our lifestyles. We are already finding in various parts around the world, particularly the developing world, that people are beginning to feel the crunch of the water crisis, if you will. One of the statistics on this slide that I find particularly interesting is that unsafe water and lack of sanitation causes 80% of sickness and disease, which kills more people than all forms of violence combined. I mean, you think of Detroit and the murders that go on in Detroit every day and multiply that by 1,000%, and you're just beginning to understand the number of people that die every day due to lack of access to clean water. The UN and UN partners, I'm sure you've all heard of the Millennium Development Goals. They have been developed as a means for the global community to get behind and build consensus for development. And of the 8 Millennium Development Goals, as you read down the list, you can see how water either supports meeting all of these goals, which also brings us to the larger question: if we don't have enough water, how can water, or the lack of water rather, lead to potential failure to meet these goals? So we're all familiar with the idea of supply and demand. We have an increasing demand for potable water that centers primarily around population growth. In conjunction with population growth, we have an increased need for agriculture, horticulture, and so that is also increasing our use of freshwater sources, available freshwater sources. Irrigation uses about 70% of our freshwater sources currently, and that number is growing exponentially every day. Additionally, industrialization is increasing our use of water, again, to support the lifestyle that we have certainly in an industrialized country, but also as the developing world becomes more industrialized, the water usage for those kinds of approaches is increasing significantly. So those are the pressures on the demand side of the scale. At the same time, we have a decreasing supply. Our supply is decreasing due to pollution. We've got 2 million tons of waste are dumped into our water sources every day. We have increased urbanization. So as the density of population increases, again, so does the impact of human beings on water sources. Climate change is certainly an influencing factor in our decreasing supply, as is our aging infrastructure around the world. The infrastructure that we have for water treatment and distribution is becoming less effective every day. So with a decreasing supply and an increasing demand, we can assume that we're going to be approaching a potential world with massive water shortages. That may lead to the privatization of water sources, which may lead to the water resources being in the hands of the haves, increasing gaps between the haves and the have-nots, and that is a ripe situation, history tells us, for violence and revolution. We're seeing some indicators of this already. For example, in Saareau city in Iraq, this was a study that was actually done by Department of Defense. And they were seeing that a lot of terrorist cells and a lot of violence were occurring in the northern part of Saareau city. They said, why? Why is it happening there but not in the south? And so they looked around, they talked to different people. And one of the things that they were finding is that the pockets of violence were in direct relation to where power was in short supply and where potable water sources were in short supply. So as scarcity of utilities increased, so too did the density of violence. Now this is a local context, but we can assume, we can think about as water shortages increase, we could very well have more violence in these local areas, and it could spread to state, region, global problems. So my colleague will talk a little bit about some of the technical approaches we might want to think about to mitigate the supply and demand curve so that we can get around some of these potential sources of conflict.
Okay, so some of the points that Melissa just made, there's one that I would like to focus on before I move into the technology, just to kind of put a real face on this problem of scarcity of water. While we're sitting here in this room, I want you to count on your watch. Every time 20 seconds ticks by, a child under 5 dies due to an illness related to waterborne disease or lack of clean water. And so if you think of that, this is a very real problem that has impact constantly as time progresses. So it is something that certainly needs to be addressed, and we're talking about technology in this session today. And so I'm going to show you an example of one technological approach that our company has worked with. To get water to the surface, there's lots of water on the surface, but it's usually polluted. It usually has some kind of contaminants in it. One way that we've gotten clean water from the ground is hand pumps. Well, hand pumps work great, but they can only go down so far. Most of the developing world, they power wells. They don't have electricity from the grid, so they use diesel generators. Well, at any given point, depending on whose figures you use, half to 2/3 of the diesel gensets in the world are inoperable, either due to lack of fuel, lack of spare parts, or lack of maintenance. And so transporting fuel and maintaining a diesel engine is difficult, and it's a time-consuming thing, and it doesn't always work. It's not sustainable. Just a moment. So one of the platforms that we've come up with and that we use on a regular basis is we need a sustainable power source. Well, more sun hits the Earth every hour than the entire globe consumes in terms of energy in a year. So it's just a matter of how you harness that energy and put it to work. So this is a solar water purification platform. Essentially, think of it like a 3.5 kilowatt generator you never need to fuel. And it produces electricity 24/7. It's got you can see inside the opened up version, it's got a water purification system this is a freshwater one that focuses on sediment, carbon, and then UV. Basically, it takes surface water or groundwater and it makes it potable. There's also versions that will do reverse osmosis, and it's a great portable solution. You take it out to an area that doesn't have clean water but has sun. You plop it on site. 15 minutes later, it opens up like a flower. You're producing clean water. Everybody's happy. So this is a wonderful piece of technology, and we have 60 of these systems around the world, and they are field proven. They're operating in Iraq, Afghanistan, Darfur. We have them in Ethiopia, Haiti after the earthquake, and we have some really wonderful success stories that have come out of this piece of equipment. So this is perfect, right? Well, not always. We have in Iraq, it worked well to lower insurgent activity. The U.S. Marines were using them as far as civilian reconstruction. But in Afghanistan, it caused conflict between villages, and these units were blown up. Some villages had water, some did not. In Darfur, it stopped a cholera outbreak. That's wonderful. But then rebels came in and destroyed some of these machines because, again, it was the haves and the have-nots. It actually caused conflict. In Haiti, they did provide water, and actually we've seen over the years, if you provide water to a community, that community, in this particular instance with the school that I work with, during the earthquake, their walls were destroyed. But there was no violence, there was no looting, because they had worked to provide their community with the water and electricity that they had needed over the years. So that is a success story. So technology is wonderful, but it's not the only solution. There have to be the soft side, the human side, to implement that technology in order to make it successful. So I'd like to leave you with, what is your criteria for success? Is it just that something works in the lab? Or is it something that actually works out in the field and is sustainable? Does it prevent conflict? Does it cause conflict? I think the thing that I would like to leave you with is there are technological solutions from all areas of industry. And as they go out into the field, especially in the developing world, it's a very different thing to make things work long term in providing water to populations that don't have it, as opposed to just making it work here in the States. So just think about how to actually implement the soft side rather than the hard side of technology. Thanks.
Well, good afternoon, everybody. My name is Jeff Balu. I'm the Marketing Operations Director for GE's Water and Process Technologies. Related to this topic today, what I thought I'd cover with you is really kind of two categories. One is just how our business is looking at the water scarcity issue on a global basis. A couple charts on that that I think apply to this supply-demand scenario that might be, just good visuals. And then a couple of case studies of some of the different technologies that we offer for our industrial and municipal customers that I think are translatable. Some of them are from the regions we're talking about today, some of them aren't, but the technologies translate, doesn't matter kind of where in the world we are. So how we're looking at the water scarcity issue, it's really kind of three main buckets. It's not just simply how much water is available, but also what quality is that water and how it's connected to energy. We could spend a whole day just talking about how energy and water are interrelated. It takes energy to make water. It takes water to not just produce electricity like at a coal-fired power plant, but rather to harvest the fossil fuels from the earth. All those things are very water intensive and are becoming more and more water intensive. I won't go way down that bunny hole, but just know that it is, and if you want to know more, just give me a call. Globally, the supply of water is roughly 4,500 billion cubic meters. I'm only a civil engineer, but that's a lot of water. 4.5 trillion cubic meters is what's available. I'm sorry, is what's withdrawn. The problem is the supply is only about 4.2 trillion cubic meters. So you say, well, how do we make up that gap? We can't be pulling off more than is available. Well, in reality, we can, because there's a lot of different technologies that I'll show you in a little bit of how we can really increase the supply that's available just by reusing streams that would normally be disposed of. And that's kind of the business we're in. If you just boil it all down, of everything that we do for our industrial and municipal customers, it's really, we're helping them make more water. In the future, just going out 10 years, and I saw a chart the other day that took this out another 20, you can see the gap gets bigger. And so we need to do more of these kinds of things. That's assuming we don't change any behaviors, but it's a pretty big gap there. And so it all comes down to a supply and demand issue. In looking at how water is used, this is another thing to keep in mind, and this is broken apart by various countries in the world, but roughly it's a 70, 20, 10 kind of combination. About 10% of the water that's usable in the world is used for sustainability of life, drinking water and cooking and so on. About 20% of that is used in industrial applications, and about 70% is used for irrigation. Irrigation is a big issue. It's one that our business doesn't currently address, but I think is another key component here to making more water available for the life side of these three buckets. This is the one that I really wanted to get to, because this, I think, kind of highlights what we do. If you consider the kind of a continuum here of water quality and then the demand for food, irrigation, industry, and life uses, going left to right across there, this is pretty much what we do today. For the most part, we take surface well water, good quality water, and use it for all the applications. You know, you go to a golf course, they're irrigating their golf course from the water from the municipal water plant. An industrial cooling tower, even here at the university, I'm sure, very likely uses city water for those industrial cooling systems, and then of course life. So the question is, well, how can we change that paradigm a little bit? Well, one way would be to be able to take lesser quality water and use it for life, and those technologies are possible to take more brackish water, seawater, whatever, and turn them into potable water for us to drink. But in addition, we can take lesser quality water, gray water from municipalities. The water that would be, the next step would be to dispose of it and send it back to the earth so that the earth can recycle that water. Well, we can take that water and send that to some of the right applications in industry or irrigation. And then lastly, take the lowest quality water all the way down to seawater and turn that into water that can be used in those applications. So there's technologies out there to make sure we're using the right quality water in the right application. And the more we do that is what makes up that orange gap 2 slides ago. So a couple of examples I wanted to share with you today. I think I've got maybe 5 or 6 here. We might not go through them all. But this first one here is a refinery down in Argentina. I won't read the slide to you, but essentially they were having effluent problems with the quality of the water that they were discharging. They were saying, how do we get our discharge to be higher quality and not send some of these things into the river, the La Plata, the Rio de la Plata. We want to stop doing that. Well, what we helped them do was take that discharge, clean it up just right, and send it back to their industrial applications and cooling towers. It required a specific chemistry to be able to accommodate that pretty cruddy water. I think a little bit of cleanup in advance of the chemistries. But the bottom line is now that water doesn't go back in the river, but instead goes back in an industrial application. And then the other side of that story is, depending where you are in the world, well, now that's a set of a quantity of water that doesn't need to be pulled from the freshwater sources. So now that's available for life use. Same kind of story here in Kuwait City. In this particular case, they had as you might imagine in Kuwait, a water scarce region. The struggle was we need water for irrigation and we need water to live on. How do we sustain both? And the answer was to implement some of our filtration and membrane systems to clean up some of the wastewater to be used for irrigation, and then that freed up that quantity of water then for drinking. So again, it's filling in that orange gap. The third one I've got here for you in Singapore is this is another scenario where we've taken wastewater from industrial applications, treated it to the, I think, did we take this all the way to direct use? No. No, we only took it to the indirect potable reuse application. So for toilet flushing, for laundry, that kind of thing. But again, limited supply of water, use the right water in the right application, and you free up for life use. And there was one more that I really wanted to get to here, was this one. And this obviously is not in one of the conflict regions. But the point is, on this chart that I wanted to share with you, what we've done here is created a wastewater treatment plant right within a community. And I think a lot like Mickey and Melissa were talking about, being able to get down to the local level is key. And so really those industrial applications, those same widgets can be made at the smaller level to support community efforts. In this case, it's 1,400 homes in Missouri. But the end result at the end of the day is, again, that much less water they have to pull from wells or from surface water, but instead use it for their local indirect needs. That's all I had. I think my time's up. Thank you for yours.
Good afternoon. My name's Chris Saareau. I am a water and sanitation technical advisor at Catholic Relief Services, and my colleague Dennis Warner and I are very grateful to Villanova to have this opportunity to come to you and start a discussion, at least bring in, from our perspective, bring in the academia perspective on water and conflict. And for me personally, in the work that I do, I'm more close, part of my responsibilities are to provide technical assistance to our country program. So to participate in this session on water and technologies is important to me, and I hope we'll get to some comments and questions later that I can use to talk to our country programs on. But I'd like to just start and just say, I know last night's session was well attended by many students, but I just want to put this in your mind that most water development projects fail. I don't know the percentage, it's been studied, but most water development projects do fail. I'm not saying, this is no reflection on what you just heard, of course, but I want to take what you just heard, these different technologies, and expand a little bit on the work that we do at CRS and how it fits into to a bigger picture and some complementary work in the development sense. And we just heard about groundwater development technologies, tools and technologies. We heard about water supply and water purification technologies and these industrial applications, more municipal, higher technologies than what we as a development organization are usually involved with. I'd like to start with our approach. As the work that we do, we take a watershed approach to our work. We look at a watershed, an area bounded with boundaries that has a single exit point where water flows out of. And we're adopting as an agency this IWRM concept, Integrated Water Resources Management concept, where we're looking at, with our programming, our water sector programming, and our agriculture environmental programming, looking at the balance, taking an inventory of what water resources are available in our project areas, looking at the multiple uses of water. What do the communities use their water for? Domestic uses, agriculture, small home gardens, food processing, for those of you who drink beer making. And that's where these different technologies come in as we talk with communities and get an understanding of their water needs. It's thinking of the technologies as you just heard and others to discuss with them, what's appropriate, what do they will feel comfortable about, having community discussions. Again, as we come together talking about water and conflict, discussing with communities, upstream communities and downstream communities, how, and looking at it in a watershed picture that everyone has an impact on the water resources in this project area, in this watershed. And hopefully through these discussions that alleviates, prevents conflict from happening, or if there's existing conflict, getting communities to talk to one another to mitigate any problems. And as Mickey mentioned, there's the software issues. We just heard again about hardware, but what we say in my industry is that the hardware is the easy part. It's the software that's the difficult part. It's easy, relatively easy to dig a well, put in a borehole, install a hand pump, bring water to the surface, cap a spring, pipe it down to a community. But it's the behavior change. You know, why are we trying to do this work? We're trying to improve people's health. We're trying to create stable populations, which hopefully then makes us here at home in this country stable as well. How do we do that? Again, it's bringing communities together, talking about community ownership, talking about operations and maintenance. Some of these technologies that you heard about are maybe a little more too sophisticated for certain communities. Maybe they're more appropriate for more communities that have stronger education systems or institutional systems in place. Most of the work I'm involved with, we're at the hand pump level, simple technologies. Talking with communities about operations and maintenance again, the financial responsibilities. Some of these systems, again, you know, what is appropriate? Can a community come up with the resources, the financial resources to sustain systems, to replace spare parts, and hopefully eventually replace these systems when they break down? Or again, do they go back to their old contaminated water source, or do they wait for an NGO to come in and replace their system? And again, I get to this concept again of appropriate technology. If they don't have the financial resources, then what do we do? If they can't maintain this hand pump and keep their borehole clean, then what do we do? Is it just a simple rope and bucket, you know, for $1.25? Is that appropriate for them? I say no because it's not a hygienic system, but again, it's having these discussions with these communities to understand everyone's responsibilities and having the community take ownership. The private sector, you know, where's the private sector involved with this? You have these different technologies that are used, but again, spare parts, where did the spare parts come from? Is there a market for the community to buy these spare parts? Do they have the funds to purchase these spare parts? What we've heard today is innovation. You know, it's good from the private sector. For me to hear the private sector talk about innovation, using solar technology on a trailer to pull it in some remote area to use some suspect water source and purify water for people to use. And again, you know, is it what's affordable? How can these systems be sustained? And just the last point that I want to make: we're at a university today. We're at Villanova. You know, how do we engage with the academic community? What thoughts do you have? During the Q&A session, I hope there are some questions that you have. We had some great questions last night. But again, from our point of view, we're trying to develop guidance to prevent and mitigate conflict around water and sanitation. You know, you heard the opening plenary, hopefully earlier today. You heard some talk on technology, maybe health earlier today. How can the academic community support us in the work that we do, this development humanitarian work that we do, and I just leave that question for our right now for our question and answer period. You know, how can we engage with the academic community and the work that we're trying to do? So, some questions.
Okay, thank you. Well, this was a very efficient panel, so we now have actually more time for questions than we had budgeted. So now it's your job to fill our time and ask some questions. So, first question, anyone?
Going to the trailer solar desalination, that was pretty neat.
But maybe use the microphone, it's a narrow room.
Going to that solar power desalination trailer, and also some of the other technologies, but that one stuck in my mind. How does like the maintenance on some of those work? I mean, if you're out in the middle of nowhere and you have those installed, and then there's electrical failure, there's probably no electrical engineer out there, electrician. I'm just kind of curious how that would work, and I mean, how much of a challenge it was to overcome.
It's not a perfect technology for every application, but one of the things that we try and do as a company, and our company tries to come at this from a development point of view. Many of our employees in the past and present have been ex-Peace Corps, and so we try and look at it from how is this going to be used in the field. So one of the ways we've tried to accomplish that is those machines actually come with a year's worth of spare parts and supplies with the machine, and so everything that's in that cube when it's folded up to pump water, to purify water, and to store water is included in that, and to help it live for its first year. After that, then there is a reoccurring cost. You do have to have some means of the community coming up with a funding source to pay for that, and so that's a whole nother issue. On a cost per gallon, that machine will actually produce water at 9/10 of a penny per gallon, which is by far the cheapest way that you're going to produce water. If you're doing it with diesel, you're many dollars to $15 a gallon. So the economic argument is there, the technology argument is there, but it's that soft side. Nobody in the village has ever used anything but a car battery in terms of their exposure to electricity. So there absolutely is a learning curve, and that needs to be addressed.
Good. Another question?
So this might not be your area of expertise, especially since you're in technology companies, but there were 2 points that I thought were kind of interesting and conflicting at the same time. One person mentioned that one of the reasons why we have a water scarcity is because of a population boom, and then another speaker addressed the issue that every 20 seconds a child dies from the lack of water. And I was just wondering if it seems like there's a lot of emphasis on we need to produce more, we need to find more, we need to make more. Do you know of any movements or technologies that are being developed to help limit our water usage? Or, obviously the population control is not something that we can really handle, but maybe if we used it more responsibly, we wouldn't have to produce as much. Is there anything out there that you could point to and say they're working on it?
Well, I think, Jeff, a lot of what you were talking about was kind of directed to that, so maybe you can kind of cast it around that, response to that.
Would you ask the first half of that question again?
Just, is there somebody out there that's trying to conserve water and to address the issue of using water more, more responsibly, rather than just the demand is going to be this, let's anticipate this demand and design for this demand, versus can we lessen the demand?
Yeah, I mean, am I on here?
Yeah. Just have to speak into it. It's not that
Yeah.
high up.
Let me move this over here a little bit. I think globally, first of all, it's a local issue, right? So here in Villanova, we don't have a water scarcity issue, but in other parts of the world, obviously we do. So, and in those areas, yeah, they most certainly are. And in addition, there are corporations, GE included, but others that come to mind might be Nestle or Coca-Cola, other companies out there who are taking the whole water scarcity issue very intelligently and very proactively. Regardless of whether they have a scarcity issue or not, they are trying to conserve more and more water. And our technologies are often part of that solution, how they do that and how we do it as well. I think in general, I mentioned the irrigation thing being about 70% of the consumption. That's a big issue too. I have pictures in other presentations I've given that show, just broadcast irrigation where you know that most of that water is being evaporated and not really feeding the plants. That's another area where the technologies exist, but the economics don't make sense yet. And so I think taking that a step farther, the countries that are trying to make conservation a bigger issue have taken it to the point where they're putting mandates in place. And there's, even in our own country, I mean, I was in Arizona not long ago where a manufacturing company could not expand their manufacturing footprint because it would require more water, and the local municipality said, no, here in Arizona, this part of Arizona where you sit, you can't have any more. You're already using your allotment. So on a local level, they are. We just don't necessarily feel it where we sit, and it's growing more and more. Israel's top of the list. They have all sorts of water conservation programs in place because in their part of the world, it's really critical.
Right.
Actually, in the work that we're doing too within our IWRM watershed work, we're also looking at, like Jeff said, these irrigation practices. Instead of flood irrigating, looking at drip irrigation technology that releases smaller amounts of water over a longer period of time so that water is not wasted, especially, and I saw this in Ethiopia, and definitely a above ground resource poor area where to see hillsides transformed on how water is used and collected and stored for future use, it's pretty amazing to see. So I'm happy to see our country programs taking that type of approach.
Another question?
I actually kind of have two questions. The first one is maybe brief and the second one is longer, but maybe for Mr. Dunscombe, do you find that local communities are pretty accurately able to tell you where they're going to find water? If you go into a community and you're looking for a place to drill, if you don't have the geophysical assessment tools available or whatever, do communities typically know where they're going to find water?
Sure, that's a very good question. And the answer is yes and no. As the previous questioner was alluding to, very often it's a problem of quantity of water, but it's also a quality issue. The village that I was working with in the Dominican had a historical place where a seep would occur off the side of a hill. That's where they would get water. However, it is just loaded with fecal coliform and other issues. It's got lots of surface water type problems with it, contaminants. And so the question is really, where do you find a potable water source? And very often that is not as obvious as it may seem, for two reasons. Many of the locations, and I'm sure the panelists here could probably say a lot more on this than I do, Ken, but the first reason is many of the locations where there's water scarcity, or potable water scarcity, is because there's a water scarcity. The other aspect is a lot of these communities live in the poverty, below the poverty level. So it's a matter of economics, it's a matter of where the water is. It's been said that the U.S. Exports an enormous amount of our water in the form of grain, and speaking to the agricultural aspect. And so how do we use water most effectively in those areas where we have it, and then create potable water in those areas that we don't? Also, building within the community, and I think we all know this, you can throw money at a solution, but it'll fail. You really need to work within the community to build them, and we were already saying that, to build within them the sense of ownership of whatever you're doing, and then the excitement and the understanding of what it means to have that health, that potable solution, and how to maintain it. So it's a very complex solution. And very often that solution is not obvious to someone who's not well educated, although they may know that there is water here coming out of the hillside or whatever.
Thank you, that's very helpful.
Maybe Chris, add a
Just
little bit to
a
that.
quick question. No,
Yeah.
I had a question and then a comment and then a question. No, I've lived with communities who would do a surface survey, looking at the type of trees growing, and say, oh, you're not going to find water here because this tree is there, but you'll find it because this tree is here. But a question for Jeff, I guess, to add on to your question is, what is your take on water divining? Because I've been to some places where they swear it happens. I have not seen it in practice, but you get the local water diviner who's experienced, and I just want to hear your take on that.
Maybe I can, unless you want to field that one.
No, you met him, right?
Are you a witch or something, or you have some
Yeah.
special
No,
talent?
no, did you?
You met Mark,
direct
not
your
Jeff.
question?
Oh, to Mark.
Mark.
Okay.
To Mark,
Oh,
okay,
oh,
okay.
whoever, if you have experience.
You know, and
Oh,
this
okay.
is really quick, funny story. Within Schnabel Engineering, we have our own technical seminar annually. And so I was thinking, I really should present something from a geophysical side this one year. My boss said, you ought to do something way far. What about like water leaching, And so I did some research on this because I get that question often. And the research is, quite frankly, there's not a whole lot to it. Yeah, however, I'm talking about double-blind survey tests where people have said, oh, I can find it using this. And you get a whole spectrum of people who use certain types of metals in the field, also who can look at a topographic map, and there's a whole group of folks. And the results from this double-blind test on a plot, you couldn't get a better scattergram than the results. There was absolutely no trend to it whatsoever. However, that said, and I'm putting my professional, on the line, I've been out in the field where people have shown me things that were uncanny with certain things. I'm not saying that means anything. I'm saying that there's some strange thing there. If it's within the person or not, I don't know. I personally don't think there is anything there. How about that for a very non-committal? Yes. So anyway, the questioner had another question.
Yeah.
Yeah, I don't want to hog the mic for too long, but just briefly, I did a case study last month in Nigeria on behalf of CRS in an area where there's been conflict between different religious communities. And the premise that the local partner had was that they could put in a water infrastructure project, probably a borehole, in between these two communities as sort of as a platform for peace building, like physical infrastructure around which they would build that peace building. But the question is, you gave the example of doing a geophysical analysis where the best site for a water point came in the middle of an individual's field, and it had to be moved, fortunately, to another area that was also feasible. But if you start trying to handle the conflict dynamics around water, particularly around something which is physically located, it can't be moved, maybe populations are moving around it, what, if anything, what kind of advice would you have in terms of just making a physical water infrastructure sort of sensitive to conflict in that way?
I'll give a very brief opinion from my perspective, and then I'll pass it off to anyone else who can answer that, and probably better than I. My personal opinion is that you can't solve a water problem in any community without working with the people themselves, because it is a societal issue, it is a cultural issue, there's all sorts of other things that come into play. So you really need to work with the community. As far as conflict, I think it's also very important, and I think NGOs are finding this, they already know this. Through the past, say, 50 years, it's become enormously evident that if you come into a community solve the world's problems or their problems and then leave, again, it's going to fail. And so you really need people on the ground who understand, who have relationships with those folks, who understand the cultural issues at play, and then really work within that framework to bring a solution. To ignore that will bring a solution that, in my opinion, is likely to fail. So that's my opinion. I'm going to pass it on to folks who are more knowledgeable about than me.
I guess maybe one thing I didn't make clear is if the most water relevant location for like a borehole is not the most conflict relevant location, like the most equidistant location between those two communities or something like that. Is that just a case?
It's more the context where water is actually being used to mitigate conflict. The conflict is not over water, but they're using water to bring communities together by installing a borehole where both communities can use the water, and then using members from each community to participate in the management of the system. So that's how they're bringing the communities together. So it's not necessarily conflict over water, but they're using water to bring communities together. But if the borehole falls within one community, I guess your question
that
is
community could be targeted by the other. I mean,
right.
that's
Right, I guess it depends on the type of I guess the geologic conditions.
That's the answer to the question. Think of the future.
Think of the
children.
future.
Yeah.
That's right.
If I can break in just really quickly, as people are leaving, when I brought a number of pamphlets here from Geoscientists Without Borders. They're in the back. Feel free to take them. I frankly don't want to bring them home. I'd rather that you have them and have a sense of what the organization is doing. So that, I'm going to turn it back to the baby. Yes.
Yeah, will they grow up?
Any other questions? Yeah.
Quick question. Hope I'm not loud enough, but there was no discussion about water testing. I know GE has a new technology that's very easy to test water. So how do people know in these communities that they're drinking bad water? If we tested and they knew ahead of time, they might still drink because they don't know the other source. But is that something you can talk about?
Only in so much as to just clear up the technology that you're talking about that's new. It is revolutionary, but it's industrial testing.
Yeah, I know. But could it be used for third world?
It sounds reasonable to me. Like I said, I'm just a civil engineer, but the PhDs back in our lab could probably give you a much better answer to that. Unfortunately, I don't know. I don't see why not, though. Right. Some of the constituents that we're talking about are applicable in both cases, but what you're really looking for, like coliform, that's a whole different set of issues that we're not really looking at from our perspective.
From where I sit, we tell our country programs to test the quality of the water before, in the beginning stages of discussions with the community, exactly what you said, to make sure that the water is consumable, or if not, what are the problems and can it be treated? That's what we consider during our planning stage, as we're discussing with the community about why water, why sanitation, where are the available water sources, and then how much water and what is the quality. So we tell our country programs that you're supposed to do this up front in the beginning, no sense designing a complete system and then knowing that the water is high in arsenic, fluoride, or if there's fecal contamination, maybe there's some type of fencing, some type of watershed protection measures that need to happen. But yes, you're right, water quality is high on our list of activities before a project is implemented, or even designed. But it's difficult, where do you do it if you're in the middle of nowhere, Kenya? There are portable water quality testing kits, very sensitive to time and to temperature, and if contamination of the media itself, if people are not careful on how the equipment's being used. So there are great concerns over that. It's difficult, and to collect a sample and take it to a national lab, if the national lab exists. issues, but we direct our country programs to water quality testing.
Let me ask a question, take prerogative of maybe the last question. And maybe I'll start with Jeff, and if Mike and Melissa maybe can find a way into it as well, that'd be good. Looking at the solutions that GE's come up with, they're great. It's clear that the economics are driving that because there's big opportunities there for the need, but also there's customers with the opportunity to pay for that. Do you see, I guess, do you envision a set in economics that would start to transform those technologies, to start to bring them into some of the areas, for example, where Mark was and all? A lot of what can drive this is an economic case at some point in time. And clearly, GE is where it is now because that's what makes the most value for its stockholders, and that's what it should be doing. But is there a case that they can make, that you see maybe emerging in the future, where that also might have this trickle-down effect?
I don't know if we have line of sight all the way to that level, to that local of a level. It is certainly what we're trying to do, and what we see prices coming down, we see prices of water going up, and that's what brings the economics together. As more and more countries look at what the real value of water is, that it's not actually free, and then at the same time as we find ways to manufacture our equipment more efficiently and less expensively, and also the other big part of it is how to operate them using less energy. That's the other big component to the cost aspect. That comes down. I don't know if we can get all the way to the gap, at that local level that Mark's working at, but we're certainly headed that direction. It's trending that way. Just by when, I can't say.
Okay.
Well, certainly as you provide more potable water.
Yeah.
Thank you. As you provide more potable water to a lot of these localities, you'll see an increase in production, an increase in the economics and the per capita of that region. So that's one economic argument, but of course that's fairly long term. There are certainly models, particularly using a product such as the one that World Water has, whereby it can become almost like a water kiosk. And you can have local people who are in charge of this technology, and instead of local people, residents paying 12 cents to someone who is providing them with questionable water, they could pay maybe 2 cents to the local water kiosk person, who can even take the system from village to village to village and increase their market base, if you will, utilizing this technology. So it can become a micro business for a local person. It can then provide clean water to people, which will then potentially increase productivity. Furthermore, by bringing this sort of technology into the local space, it can help maintain water rights and water resources in the hands of the local community. Because as you were saying, people are becoming more broadly aware of the value of water. And as that continues to happen, we will see more industrialization, more privatization of water. If we can keep water rights and water resources in the hands of local people instead of these multinational organizations, governments, Nestle, for example, number one, that would help poverty reduction, it would help equality, and it also helps prevent the transport of water resources. You'll hear, for instance, even in this country, Nestle takes water out of the Great Lakes and transfers it to Texas. Well, who does that water belong to? Does it belong to the people who live around the Great Lakes? Does it belong to the people in Texas? Nestle thinks it belongs to them. So these are all questions that some of these technologies, particularly these local technologies, can help level the playing field, if you will, economically.
Okay, thank you very much. I think just to kind of summarize what we've heard, we saw examples from Mark about how technology really can be brought to bear to find water. And we heard from Melissa and Mike about, again, more technology, but the importance of it's not just technology by itself. Technology does work, but it can't be a sustainable solution without looking at the bigger picture. And I think Chris echoed those thoughts as well, but then kind of challenged us on the academic side. So what is it that we can do in academia to also help bring some answers to this? So I think it was a very complete panel. I want to thank the panelists. Please join me in doing that. And that concludes our session. Thank you, Mike. That was great. Appreciate it.